Part A is asking you to find dy dx. So we're going to differentiate. So we take the derivative, which would be negative 16x. Now here we have product rule, so we're going to do the first times the derivative of the second, which is dy dx, because whenever we take the derivative of a y, we write dy dx, plus the second, which is y, times the derivative of the first, which is 5, plus now the derivative of y cubed, which is 3y squared. Again, we write dy dx because we took the derivative of a y, equals 0. Okay, so we're going to take everything that has a dy dx, we're going to factor out that dy dx, and we're going to keep it on the left side of the equal sign. So that's going to give us 5x plus 3y squared. Then everything that I'm kind of squiggling here, I'm going to move to the other side of the equal sign. So that negative 16x will become positive 16x, and the 5y will become minus 5y. Now we're trying to find dy dx, so we're going to divide by what's attached to it since they're being multiplied currently. So that would be 5x plus 3y squared over here, which we'll cross that out. And then over here, 5x plus 3y squared. So finally, dy dx is going to equal 16x minus 5y, that whole thing, over 5x plus 3y squared. So this is your answer for part A. Part B is asking you to write an equation for the line tangent to the curve at the point 4, -1. So recall that when we're writing the equation of any kind of a tangent line, or any kind of a line really, y minus y1 equals m times x minus, x1. Okay? All right, well, we have our x and our y value. We know that our y value is -1, so that's going to be y plus 1 equals, and we're just missing our slope right now, and we have x minus 4. Now remember, slope is right over here. It's our dy dx. So all we're going to do is we're going to plug in for dy dx. We're going to plug in 4 for our x value and -1 for our y value. So we're going to do 16 times 4 minus 5 times -1 over 5 times 4 plus 3 times -1, that quantity squared. Okay? So we end up with 64 plus 5 over 20 plus 3, which is 69 over 23, which when we reduce that will give us 3. So then the equation of our tangent line would be y plus 1 equals 3 times x minus 4. Okay, and let's just double check. Yes, that is what they asked for. Now, while we're at it, we're going to look at part C because we can fit that all on here. And part C, if you read the question, it's asking you to find the number k such that we have this point 4.2 comma k that's on the curve. And it says to use the tangent line that we just found, which is boxed over there on the right, to approximate that value of k. Well, we do know that here this is an x value and that this is a y value. So simply what I would do is take your tangent line that you have over there boxed off on the right and just plug those values in and see what you end up getting. So we're doing k, because that's the y value, plus 1 equals 3, that's an equal sign, times 4.2 minus 4. Okay, so then we have k plus 1 equals 3 times, now 4.2 minus 4 is 0.2. So then k would equal 3 times 0.2, and 0.6 that would be, right? And then we're going to subtract 1 from that. So then k, now again, this is an approximate value, So when we subtract, we're going to get approximately negative 0.4. And that is our answer. So all they really want you to do is take that tangent line that we did get, and they're approximating a value given an x value and wanting you essentially to find the y value.